Yeah, this is joint work with Stefan Kugelmann and Bernhard Rumpe, my professor. And I have the management title on the top and what we actually do in the middle. So it's about defining unparsers within context-free grammars. And so perhaps a little bit about me to get this into the right context. Actually, I am not from the security research stuff. I'm doing software engineering. So bear with me. I used to be a pen tester, and now with software engineering, as I said. And I always wondered, why is cross-site scripting that hard that nobody gets it right? So what is the fundamental problem with it? And in the end, yeah, I ended up at LangSec. So let's see how this comes. So as you all might know, cross-site scripting and SQL injection are problems where an attacker puts some malformed input into a front end in here and then manipulates some generated or some other language which is generated from this front end. For SQL, this is okay. So basically, what to abstract from this, these are injection attacks, and some are different. But to generalize these, the front end needs to unparse into some language in order to talk to some kind of backend. So this is a usual setup where you always find these injection attacks. Might be the target, as seen here, might be again browser, or might be some backend system. So basically unparsing here. So you might say, okay, yeah, I know SQL injection is already fixed. We have some libraries for this, and also for cross-site scripting, there is work which kind of works. So why are you talking about this? Yeah, because it's not fixed for the common case, right? So if we design our own protocols, or somebody else is doing this, then the question is, how do they define their, how do they encode their stuff, right? So they would basically just use string concatenation and or whatever, and put it into their formats. So basically, I'm concerned about all these cars, all these backend interfaces which nobody had looked at, or which are implemented in the future. So to get it a little bit on the point, we have these usual stuff on the top here, where we have a string representation on the wire and need to parse it to make it somehow usable for an application. And then afterwards, when an application back talks to bring this on the wire again, we need to unparse it. And so a usual round trip would be that for every AST, we would expect that when we unparse it and later parse it, it gets again the same AST. That's nice and true for COM input, but if we inject, or if an attacker injects some malicious input, wire some whatever way into this application, and the application wants to put that into a document, so basically putting it into an AST, some control characters, and then we unparse this. We get a different data structure, so a different message on the wire, which is not what the developer expected. So what we actually need here is that even in the way in unparsing, that these special crafted messages, these are correctly encoded and decoded again when parsed again. So as we are lazy, we don't want to write these parsers and unparsers by hand, so we want to generate them. So we actually implemented or extended a tool called Monticore by, so we have here our grammar, and this Monticore tool is basically a parser generator. So we generate parsers from them and unparsers. And what we actually did here in this work is that we extended these definition of grammars with this encoding table down here. on a per token level. So it means you can define within the grammar that everything which is in this token is encoded, or some tokens get encoded within this token. So these special characters here get encoded, so they do not interfere with other structures. Exactly. So so we want to do this for languages which are more complex. So basically for SQL, this would be enough. You just write, okay, we need to encode these characters here. But if it goes to more complex languages like HTML, we have more embedded, different embedded contexts, which are embedded into each other, and it gets more complicated. So what we use here as technique is the language composition, which is basically that you define one grammar per language and put into this language another language, so that or you concatenate these different languages by replacing a terminal symbol within the supergrammar, and that way you can embed like JavaScript in HTML also. And you would then, like on the previous slide, define the encoding per token. So basically you don't need to cope about interference between languages. And now, when we want to unparse these composed languages, we need to start from the bottom first, and then you run the unparser, run the encoding, and then put this one into the more top language unparser. And so we could use some characters within one of the sub languages, which is used in the more super languages without having trouble. So just from defining this, it gets a secure unparse process in the end, even though the developer does not have to explicitly specify this. And within parsing, it's the same way, just a different way around to get these parsing again, these encoding again within the parsing. Now, if we have the case like within forums or some other wikis or so, that we want to include some highly structured input into an output like HTML, then it might be so one option to do this is like you construct it for your output in grammar and say, okay, in this special token named like A, I wanna reduce the mightiness of the language, so I don't allow all tokens here, but just a subset. That is an idea, but that gets a little bit of a mess because you need to have a look at special namings also in your grammar. So another alternative approach would be to just limit the input. So you write a grammar for your input, and say, okay, I just use this limited input here, and then just copy it over. This is kind of defeating an output problem within input validation, which is always kind of dangerous if you do this. So the program code from parsing the input to producing the output must not change this stuff here, because otherwise something might get injected here. So to give a little bit of a wrap up here, is so how to use this, or how developers should use this, is that we have somebody who defines the language and defines with the grammar the encoding tables, and then generates parsers and unparsers. And with these decoding and encoding enabled, and then later on, developers who are just using the format can use these generated parsers and unparsers to write out their messages. And this works like, okay, they first have to create an AST. So in order for this tooling to know which context it's in and which encoding it has to apply. And then the number two, so when you have this AST, you can add the data from the input and don't have to care about how it's structured, because in the third step, the encoder will encode everything. And so because it's a pain to create an AST with program languages, we have also implemented a kind of other parsable template. So you could write a template AST which looks like your output, and we pass this one into an AST, and then the process gets like explained. So we actually did this with, so we did a case study with HTML and JavaScript, and implemented grammars for both of these, and wrote a web application which uses these parsers and unparsers, only the unparser. And then we do what one does with web applications. We did scan for cross-site scripting. And luckily, the overstep did not found anything. And then we did a manual review and found that we actually missed in some. So the encoding table was not right, and we missed something here. So we actually, just for convenience purpose, added some options. So the encoding table, you could also write in there that the matching you're defining there, that it's meant to be in case insensitive or ignoring white spaces or so. So the point is here, we are not implementing yet another perfect HTML and web and JavaScript parser. It's just to show, this is complicated stuff. We don't get it right in the first place, and we have to look at this later on, exactly. So to conclude this, we took a look at injection attacks and saw that these injection attacks have their root cause in the unparsing process where there's no encoding taking place, and we solved this by putting the definition of encoding into actually the language definition. So at a grammar token level, and then we derive from this grammar. We derive a generated encoder and decoder, which then can be used to parse and unparse these formats. And as I said, not yet another HTML encoder. So what we also find, and what is perhaps a little bit of a discussion, is that templates heavily used within web applications are some kind of harmful, because when you put your input or your input comes in, and you put these input into a template and just say, okay, we do some string concatenation here, then you have no idea which context this is in, or which encoding should apply at this point. So you have no chance to get this fixed at this point. And so we propose to no longer use these output these output interfaces which have no idea of the correct encoding, but instead use something else which knows which language the output is. So thanks for your attention, and I'm ready to take questions.
Questions? Println considered harmful. Parse it before you print it.
So you mentioned this library, Montecoder, a lot. I Googled it. I can't find anything. Is there something open source coming?
There is something coming, but the mother project Montecoder is currently in the release process.
Okay.
So we need to stuff some things in there.
Cool.
Okay.
More questions? Let's thank the speaker.